So in this session, let us discuss the differentiation of some complicated functions which cannot be differentiated directly. Here we are going to use the laws of logarithm to simplify the given complicated function into a simple one. Then we can go for differentiation. So it is said to be logarithmic differentiation. Logarithmic differentiation. Here we are going to use the laws of logarithm. Before differentiating, we are going to use laws of logarithm. Therefore, we will call it as logarithmic differentiation. See, y is equal to sin x divided by tan x plus 1. How we are going to differentiate this? We will differentiate it by quotient rule. Correct? Y is equal to x square sin x. It is differentiated by what? Product rule. Correct? Suppose if it is x square tan x log x divided by 1 minus x into e power x. See, this is in the quotient form, no doubt. But if I observe the numerator, it is of what? Product of 3 terms. Denominator is of product of 2 terms. So it is having more number of functions involved in the quotient form. So if we differentiate by using quotient form, it will be very lengthy and little bit complicated, right? That's why we are going to simplify it. We will make it into simplified form using laws of logarithm. After that, we are going to differentiate it, right? Observe this function. Y is equal to x to the power of sin x. Do you have differentiation for such function? We don't have. Then how to differentiate this? We cannot differentiate it directly. So for such terms, we have to use the laws of logarithm, then make it into differentiable form, and then we are going to differentiate it. Then what are the steps here? We have to follow it. See, y is equal to tan x to the power of sin x. Y is equal to sin x to the power of x minus x to the power of x plus 2 to the power of x. The function is of function to the power of function, function to the power of function. So they are in the sum or difference form. They cannot be differentiated directly as we have did in the previous classes. So for such functions, we need the help of logarithms, laws of logarithms. By using laws of logarithm, we make them into differentiable form, right? So this is brief introduction about logarithmic differentiation. What are the steps involved in logarithmic differentiation? Suppose if the function is given like this, y is equal to function to the power of function. It is what? Function to the power of function. So this is in x, this is also in x. It cannot be differentiated directly. Therefore, we have to take log on both sides. Take log on both sides. By taking log on both sides, we have to use laws of logarithm. Use laws of logarithm. Expand it. Expand it into simple form. Simple form. Then differentiate on both sides. So what are the steps involved here? When function to the power of function is given, first step is take log on both sides. Then use of laws of logarithm. After using laws of logarithm, we have to make them into simple form. Then we have to go for differentiation. So which are the laws important here? Laws of logarithm. See, log m into n is equal to log m plus log n. log of m by n is equal to log m minus log n. This is most important. Log m power n is equal to n into log m. The power become index. So these are important laws we are going to use in the differentiation process, right? So let us take some function using logarithmic differentiation. They don't mention, they will not mention here use logarithms to differentiate the following. They don't give anything. Just they give you like this. Differentiate the following. Differentiate the following with respect to x. They give you like this only. See the example. Y is equal to x to the power of x. I will take a simple problem. Y is equal to x to the power of x. Observe this. The base is in the form of x. The power is also in the form of x. Then what to do? We have to take log on both sides. Take log on both sides. It becomes log y is equal to log of x to the power of x. This is the right hand side. The right hand side is in this form, correct? Log m power n. Log m power n is what? N into log m. According to that, log of y is equal to x into log x. See this, it is differentiable, correct? Up to this, it is not differentiable. This is not differentiable. After taking log on both sides, it will not be differentiable. After simplifying according to the law, it will become simplified form and it is differentiable. Means it is having differentiation, right? Differentiate on both sides. Differentiate on both sides with respect to x. Differentiation of log y. It is y term. How to differentiate y term? It is similar to x term, but at the end we have to write dy by dx. 1 by y into dy by dx. What is differentiation of log x? It is 1 by x. For log y, it is 1 by y into dy by dx is equal to. How to differentiate the right hand side? It is of what? X into log x. It is of product form. Correct? X into log x. Take product rule. What the product rule states? u into dy dx of v plus v into dy dx of x. Now just written according to the product rule. In the next step, wherever we have dy by dx, differentiate it. Differentiation of log x is what? 1 by x plus log x into differentiation of x is what? 1. This x get cancelled. Therefore, dy by dx is equal to. So 1 by y becomes what? It is y by 1 in the other side, right? So y by 1 is y into. What is remaining here? After cancelling x, you will have 1 plus 1 into log x is log x. This is answer. If you want, you can write the y value. What is y value? It is x to the power of x. X to the power of x into 1 plus log x. Log x. That is dy by dx. Right? The same procedure you have to follow for function to the power of function is given. Right? Prove that dy dx of a power x is equal to a power x into log a. So I have given differentiation of a power x is equal to a power x into log a in the beginning itself. Let us prove it. It has to be proved by using laws of logarithm. Take y is equal to a to the power of x. So this is y. Take log on both sides. Take log on both sides. It is what? Log y is equal to log of a to the power of x. According to the third law, it becomes what? Log y is equal to x into log a. Now differentiate on both sides. Differentiate on both sides with respect to x. Log y differentiation 1 by y into dy by dx is equal to x into log a. Don't use product rule. See the previous example, x into log x was there. That's why we have differentiated by using product rule. Here, x into log a. What is log a? Log a is constant. It is a numerical value. So, it is treated as constant. Constant into function. Keep constant as it is. Differentiate x. Differentiation of x is 1. Correct? So, it becomes dy by dx is equal to y into log a. What is y? What is y? Y is equal to a power x. Therefore, differentiation of a power x is equal to a power x into log a. So a may be any positive integer. If you take 2 to the power of x, it will become 2 power x into log 2. If it is 5 to the power of x, 5 to the power of x into log 5. It is 3 to the power of x means differentiation is what? 3 to the power of x into log 3. Right? Next problem. Y is equal to tan x to the power of whole to the power of x. Say the given function y is equal to what? Tan x to the power of x. Function x term to the power of x term. Function to the power of function is there. Therefore, use laws of logarithm procedure. First step, take log on both sides. It become log y is equal to log of tan x to the power of x. Right hand side is expanded according to the third law. Log m power n is equal to n log m. Log y is equal to x into log of tan x. Now it is differentiable, right? Differentiate on both sides. Differentiate on both sides with respect to x. Log y, it is 1 by y into dy by dx because it is y term. Right side, x into log of tan x. So it become what? X into log of tan x. U into v form. It is product of two terms. Use product rule. X into d by dx of log of tan x plus log of tan x, log of tan x into what? Into differentiation of u. What is u? X only, right? Differentiation of d by dx of u. What is u? It is x. See the right side, x into. We have to keep x as it is. Differentiation of this function. How it is? The function is of what type? Log of tan x. Chain rule. Correct? For log x, it is 1 by x. For log function, it is 1 by function into d by dx of function. Correct? For log x, it is 1 by x. For log function, it is 1 by function into d by dx of function plus log of tan x into differentiation of x, that is 1. Now, if I want to write for dy by dx, the y goes to numerator of other side, x divided by tan x into differentiation of tan x is what? Secant square x plus log of tan x into 1, that is log of tan x. Now differentiation part is over, right? If you want, you can replace y. What is y? Y is equal to tan x to the power of x into secant square x divided by tan x plus log of tan x. This is the answer. If you want, you can further simplify here. You can take secant square as 1 by cos square, tan as sin by cos get cancelled. In that way, you can simplify it. Otherwise, you can write as it is. Okay. Y is equal to log x to the power of cos x. Y is equal to log x to the power of cos x. So function to the power of function, take log on both sides, log on both sides, that is log y is equal to log x to the power of cos x. So according to the log m power n is equal to what? N into log m. Most of the problem use that law only. So according to that, log y is equal to cos x into log x, log x, right? Now it is in the differentiable form. We can differentiate this on both sides. On differentiate with respect to x, we get 1 by y into dy by dx is equal to product rule. Cos x is u, log x is v, right? U into d by dx of what? Log x plus log x into d by dx of what? D by dx of u, that is cos x. So cos x into differentiation of log function. For log x, it is 1 by x. For log function, it is 1 by function into d by dx of function. Is it right? D by dx of log function. So according to that, 1 by function is 1 by log x into d by dx of function. What is function? Log x plus log x into differentiation of cos x. We are getting minus, therefore put the bracket, right? Or dy by dx is equal to y into cos x divided by log x into differentiation of log x is what? Differentiation of log x is 1 by x plus into minus sin x into log of log x, or it is equal to, you can write y value. What is y value? Y is log x to the power of cos x. Y is log x to the power of cos x into cos x divided by x into log x minus sin x into log of log x, right? When function to the power of function is given, we have to use laws of logarithm. Got it? So like that, we can take any function of x as base and any function of x as power, taking log on both sides, use laws of logarithm, make it into simplified differentiable form, then go for differentiation, right? See this one, y to the power of x is equal to x to the power of y. The given function is what? Y to the power of x is equal to x to the power of y. function to the power of function, function to the power of function. On either side it is of same, right? Then make this into differentiable by taking log on both sides. Take log on both sides. That is log of y to the power of x is equal to log of x to the power of y. X into log y is equal to y into log x. Now we can go for differentiation. See the left side, it is product of x and log y. See the right side, it is y into log x, product of two terms. On differentiating, we have to use product rule. Differentiate with respect to x on both sides. How to differentiate x log y? It is product, correct? X into log y. So use product rule. X into d by dx of log x, that is log y, plus log y into d by dx of what? X is equal to. And right side, again it is product of two terms. Take y as u, log x as v. That is y into d by dx of log x plus log x into d by dx of what? Y. On either side we have used product rule. Now differentiate. Wherever we have d by dx, it is to be differentiated. What is differentiation of log y? It is 1 by y into dy by dx plus keep log y as it is. Differentiation of x. Differentiation of x is 1, right? Is equal to y into differentiation of log x is 1 by x plus log x into differentiation of y is what? Dy by dx. On either side we have differentiated. Then what? We have dy by dx term more than 1. There are two terms of dy by dx. Collect to the left side. It is of implicit function, right? X by y into dy by dx. This is what? Log x into dy by dx. If it is transferred to the left side, it becomes minus log x into dy divided by dx is equal to, on the right side we have y divided by x. Then we have not written so far log y. Why? It is not having dy by dx. We are taking it to the other side. If I take to the other side, it becomes what? Minus log y. Then take dy by dx common. Dy by dx common. So x divided by y minus log x is equal to y by x minus log y. Or dy by dx become what? First write the right hand side term, y by x minus log y all divided by x divided by y minus log x. Further, you can simplify it by taking LCM on numerator as well as at the denominator. Suppose x is LCM, x into y minus x log y. At the same time, in the denominator, y is LCM. What you will get? X minus y into log x. If I simplify it, so this x goes to denominator, this y goes to numerator, correct? That is y into y minus x into log y divided by this x into x minus y into log x. You can multiply with y at the numerator and x with the denominator, right? Sometimes they will give you like this: y is equal to x to the power of x to the power of x to the power of x up to infinity. y is equal to x to the power of x to the power of x up to infinity. We have to find dy by dx. For such problems, you leave first x at the right side and read out the remaining thing. What is remaining thing? X to the power of x to the power of x up to infinity. So x to the power of x to the power of x up to infinity can be taken as y. What is y? Y is x raised to x raised to x raised to x up to infinity. That means this factor, this thing can be taken as y, because y is what? X to the power of x to the power of x to the power of up to infinity. Don't think there are 4 terms here, 3 terms. Up to infinity means you can take any number of terms. Okay. Now it is of what? Function to the power of function. Take log on both sides. That is log y is equal to log of x to the power of y. According to the third law, the right side term become y into log x. Now differentiate on both sides. On differentiating, we get 1 by y into dy by dx is equal to right hand side term is in the form of uv, correct? U into v. Use product rule, y into d by dx of log x plus log x into d by dx of y. Therefore, dy by dx, that is 1 by y into dy by dx. This is what? Log x into dy by dx. If it is taken to the left side, it becomes minus log x into dy by dx is equal to right hand side remaining is what? Y into differentiation of log x. Differentiation of log x is 1 by x. Why I am taken this to left side? Because of dy by dx term. Now take dy by dx common at left side. What is remaining? 1 by y minus log x is equal to what? Y divided by x, or dy by dx is equal to y divided by x all divided by 1 by y minus log x. Sometimes they give you only this part. If y is equal to x to the power of y, x to the power of y, or y is equal to y to the power of x, find dy by dx. Use same procedure. Use same procedure. Right? So like that, for any given function to the power of function, we have to take log on both sides, and then it is used according to the law of logarithm, made it into simplified form. Then we have to go for differentiation. Right? This is the procedure we need to follow for such functions. Suppose the function is like this: y is equal to x to the power of x plus x to the power of sin x. See, the right hand side term is having sum or difference of function to the power of function. Suppose if they give sum or difference of function to the power of function, that case we cannot taking log on both sides directly, because we don't have log m plus log n is equal to, so we have a rule of this, correct? We cannot take this according to this law. Again, it will become more complicated. Then how to find the differentiation? Before taking law, you take separately, take these two terms separately as u is equal to x to the power of x. Otherwise, you take x to the power of 1 by x. We have did for x now. V is equal to x to the power of sin x. Therefore, y is equal to what? U plus v. Then dy by dx become what? Dy by dx is equal to du by dx plus dv by dx. Find out du by dx separately, find dv by dx separately, then substitute here to get dy by dx. That is the way we have to get differentiation of such function. Okay, I am taking u is equal to x to the power of 1 by x. Take log on both sides. Taking log, it become what? Log u is equal to log of x to the power of 1 by x. Left side remains same. Right side, we have to use law of logarithm. So power become index 1 by x into log x. I will take this as log x by x. Correct? 1 by x. 1 into log x is log x divided by x. Differentiate on both sides. Differentiate on both sides. Log u. So it is 1 by u into du by dx. You do same as this type of functions. Whereas by here we have a u, right? How to differentiate this? Quotient rule. Log x by x, use quotient rule. What the quotient rule states? X into d by dx of log x minus log x into d by dx of x all divided by what? V square means x square, or du by dx is equal to u into x into, we have taken u to the numerator of other side. X, keep x as it is. Differentiation of log x is what? 1 by x. Differentiation of log x is 1 by x minus log x into differentiation of x is what? 1 all divided by x square. So xx cancel. What is du by dx? Du by dx is equal to, write u. What is u? X to the power of 1 by x into, this is what? 1 minus log x divided by x square. This is du by dx. In the same way, take y term and get the dv by dx. V. What is V? V is equal to x to the power of sin x. Take log on both sides. Log V is equal to log of x to the power of sin x. Using this law, right side term become sin x into log x. On differentiating, differentiate with respect to x on both sides. It is 1 by v into dv by dx is equal to sin x into log x, product rule, correct? Sin x into d by dx of log x plus log x into d by dx of sin x, or dv by dx is equal to v into sin x. Differentiation of log x is 1 by x plus log x into differentiation of sin x is cos x. Or what is v? You can write v value. V is equal to x to the power of sin x into sin x by x plus log x into cos x. We got du by dx and dv by dx separately, right? Then to get dy by dx, substitute here. Differentiation of dy by dx is equal to du by dx plus dv by dx. It is equal to differentiation of v du by dx. Write this one, x to the power of 1 by x into 1 minus log x divided by x square plus dv by dx. It is what? X to the power of sin x into sin x divided by x plus log x into cos x. This is called logarithmic differentiation. When sum or difference of two or more terms are given, each term is in the form of what? Function to the power of function, right? So next type of differentiation, that is parametric functions. Parametric functions and their derivatives. Parametric functions and their derivatives. Let us know what is parametric function. Then we can go for their derivatives, right? Parametric functions. So far, we have taken such functions. Y is equal to f of x, or f of x comma y is equal to 0. The y is function of x, or the function is involved both x and y term together. This is explicit function, this is implicit function. But there are some function x and y will be given separately. X is separate, y is separate, but both x and y will be in same variable. See, if x is equal to f of t, means x is function of t, and y is equal to g of t, y is function of g of t, means it is function of t, y is function of t. Both x and y are expressed in what? T. So that t is called parameter. T is called what? Parameter. And such functions are said to be parametric function. So any function, if it is in this way, sometimes x is a function of theta, y is function of theta. So theta become parameter. So parameter is nothing but another variable, common variable. It is said to be a parametric variable. Okay, and such functions are called parametric functions. Both variables x and y will be given in another common variable. That common variable is said to be parameter, and those functions are said to be parametric functions. How to get derivative of such functions? See, x is given in what? F of t. Differentiate x with respect to t. We get dx by dt, correct? Dx by dt. Say I will take it as f dash t. F dash t. Y is equal to g of t. Y is equal to what? G of t. Differentiate y with respect to t. We get dy divided by dt is equal to g dash t. Means we have differentiated the given x and y with respect to their variable. If it is in t, we have to take in t. If it is in theta, we have to take it as dy by d theta, dx by d theta. By using these two, dx by dt, dy by dt, we will get dy by dx. So dy by dx. So take y first. What is y expressed here? It is in the form of dy by dt. Write first. Then x, you write x coefficient. Dx divided by dt. This is known as parametric differentiation. It is parametric differentiation, right? Suppose x is in theta, we will get dx by d theta. Y also in theta, it will become what? Dy by theta. In that case, dy by dx become what? Dy by d theta by dx by d theta, right? So I'll give you examples. It's most important. Definitely one question will be there in the examination. If x is equal to a secant theta and y is equal to a tan theta, find dy by dx. I'm taken simple example. Take x. What is x? A secant theta. Differentiate x with respect to theta. We will get dx by d theta. Constant into function. The function is in theta. So how to differentiate the function? If it is in x, in the same way, we have to differentiate the function which is in theta, right? We are differentiating with respect to theta. Therefore, it is differentiation of secant x is secant x tan x. Here, if it is in theta, we have to write secant theta into tan theta, right? Then take y. Y is equal to what? A tan theta. Differentiate y with respect to theta. We get dy by d theta. A into differentiation of tan theta is secant square theta. We got dx by d theta and dy by d theta. Therefore, dy by dx is equal to dy by d theta divided by dx by d theta. It is equal to dy by d theta is what? A secant square theta. Dx by d theta is a secant theta into tan theta. A cancel. Secant square theta by secant theta into tan theta. You can cancel secant. So remaining is what? Secant theta divided by tan theta. Correct? We can take secant as 1 by cos theta divided by tan theta is sin theta by cos theta. Cos cancel. 1 divided by sin theta. 1 by sin is what? It is cosecant theta, right? So in this way, we are going to find the derivative of parametric functions. It may be given in theta or it may be given in t. Okay. We have to follow the same procedure of any problem if it is given in the parametric form. Okay. Next problem. If x is equal to c by t and y is equal to ct, find dy by dx. Here both x and y will be given in what? They are given in t's, right? They are functions of t only. Take x is c by t. Differentiate x with respect to t. So we get what? Dx by dt. C by t. C into what is differentiation of 1 by x with respect to x? We have to use 1 by x to the power of n formula. Correct? 1 by x to the power of n formula. It is minus n by x to the power of n plus 1. Use same thing here. C into 1 by t. What is n? N is 1 minus 1 by t to the power of 1 plus 1. So finally it become what? Minus c divided by t square. Take y. What is y? Y is equal to ct. Differentiate y with respect to t. So what you will get? You will get dy by dt is c into differentiation of t is 1, similar to x. Finally, c is derivative of y with respect to t. Using parametric differentiation, that is dy by dx is what? Dy by dt divided by dx by dt. What is dy by dt? It is c. What is dx by dt? It is minus c divided by t square. It is nothing but cc get cancelled. Minus of this t square goes to numerator. Minus t square is answer. Okay. If x is equal to a into sin t and y is equal to b into tan t or cos t, let us take cos t. Get dy by dx. Differentiate this x with respect to x. It is dx by dt. A into differentiation of sin t is what? Cos t. Differentiate y with respect to t. You will get dy by dt. B into differentiation of cos t is what? Minus sin t. Write it in bracket. So finally, dy by dx become dy by dx, sorry, dt divided by dx by dt. What is dy by dt? It is minus b into sin t divided by what is dx by dt? It is a into cos t. It is equal to minus b divided by a. They are constant. They will not be cancelled. You can write the simplified form. Sin theta by cos theta is tan theta. Therefore, sin t by cos t is what? Tan t. Sin t by cos t is tan t. If x is equal to a into 1 minus cos theta and y is equal to a into theta minus sin theta, show that dy by dx is equal to, show that dy by dx is equal to cosecant theta minus cot theta, or that is equal to tan theta by 2. Sometime they will ask you such type of problems. They will ask you to get the required derivative like this. To follow the procedure, a into 1 minus cos theta, correct? Differentiate it with respect to what? Differentiate ax with respect to theta. We will get dx by d theta is a constant into function. Constant into function. Keep constant as it is. Differentiate the function. Differentiation of 1, 0. Minus. Differentiation of cos theta is what? Minus sin theta. It is what? Minus into minus plus a into sin theta. A into sin theta. Take y. What is y? Y is a into theta minus sin theta. Differentiate y with respect to theta. You get dy by d theta is equal to constant into function. So when constant into function is there, we have to keep constant as it is. Differentiate the function. Theta, it is like x. 1 minus sin theta, it is like sin x. Differentiation is cos theta, right? Cos theta. Differentiation is over. Then take dy by dx. Dy by dx is dy by d theta divided by dx by d theta. What is dy by d theta? A into 1 minus cos theta divided by dx by d theta is a into sin theta. A get cancelled. 1 minus cos theta divided by sin theta is derivative. But required derivative is what? We need to prove that cosecant theta minus cot theta. And also we have to prove it as tan theta by 2. So to get cos theta, cosecant theta by tan theta, what we can do? Divide both the numerators with denominator. You will get first answer. Correct? See, 1 minus cos theta all divided by sin theta. It can be taken as 1 by 1 by sin theta minus cos theta by sin theta. Correct? When it is all divided by each term, when they are some are difference, each term of numerator can be divided with the denominator. So it become 1 by cosec, 1 by sin is 1 by sin is cosecant theta minus cos theta by sin theta is cot theta. So we got the proof, right? First proof. How to get the second proof? See the second proof. What is second proof? It should be in submultiple angle tan theta by 2. Submultiple angle theta by 2. So for that, take the obtained derivative. It is 1 minus cos theta divided by sin theta. We have submultiple angle formula. Sin A is equal to 2 sin A by 2 into cos A by 2. 1 minus cos A is equal to 2 sin square A by 2. 1 plus cos A, they are important in integration as well as in differentiation. Use this. That is 1 minus cos theta, 1 minus cos theta is what? 2 sin square theta by 2, right? Sin theta, sin A is what? 2 sin A by 2 cos A by 2. It can be taken as 2 sin theta by 2 into cos theta by 2. 2 to get cancelled. Sin square theta by 2, sin theta by 2. Sin cancel. Remaining is what? One more sin theta is at theta by 2 at numerator and cos theta by 2 at denominator. It becomes tan of theta by 2. We got the second derivative also. Like that, if they ask for a particular derivative, you have to go for further simplification of obtained derivative, right? If x is equal to a into sin theta minus theta cos theta and y is equal to a into cos theta plus theta sin theta, get the derivative. Get the derivative. What is x? X is equal to a into sin theta minus theta cos theta. Is it right? X is in theta, therefore we have to differentiate with respect to theta. Differentiate with respect to theta. Dx by d theta. It is constant into function. Keep constant as it is. Differentiate the function. What is function? It is sin theta minus theta into cos theta. How to differentiate it? Differentiation of sin theta is cos theta, similar to sin x. Minus, it is theta into cos theta into theta into cos theta. Therefore, use product rule. Product of theta and cos theta. Put a bracket. Product rule states that u into d by d theta of what? Cos theta plus cos theta into d by d theta of what? Theta. Close the bracket. It is a into cos theta minus theta into differentiation of cos theta is what? Minus sin theta. Plus keep cos theta as it is. Differentiation of theta is what? 1. Right? That is a into cos theta. Remove this bracket. Theta minus sin theta minus theta sin theta. Minus of minus plus theta sin theta. Minus into plus is minus cos theta into 1 is cos theta. Observe the bracket. Minus cos theta plus cos theta get cancelled. What is remaining? A into theta into sin theta. It is dx by d theta. Right? Similar to that, take y. What is y? Y is equal to a into cos theta plus theta sin theta. Differentiate y with respect to theta. You get dy by d theta is equal to a into differentiation of cos theta. It is minus sin theta plus theta into sin theta. How to differentiate this theta into sin theta? We have to go for product rule, correct? U into v theta into d by d theta of sin theta plus sin theta into d by d theta of theta. A into minus sin theta plus theta into differentiation of sin theta is what? Cos theta plus keep sin theta as it is. Keep sin theta as it is. Differentiation of theta. It is similar to x. It is 1. Observe this. Plus sin theta into 1 sin theta plus sin theta minus sin theta cancel. What is remaining? A into theta into cos theta. Correct? This is dy by d theta. Therefore, you take dy by dx. What is dy by dx? Dy by d theta divided by dx by d theta. Write dy by d theta. It is obtained as what? A into theta cos theta. Dx by d theta is what? A into theta into sin theta. A cancel, theta theta cancel. What is remaining? Cos theta by sin theta is cot theta. Cot theta, right? If x is equal to a into sin to the power of 4 theta and y is equal to b into cos to the power of 4 theta, find dy by dx at x is equal to theta is equal to pi by 4. After getting dy by dx, we have to substitute theta is equal to what? Pi by 4. Take x is equal to a into sin to the power of 4 theta. How to differentiate this? We have constant into function. Keep constant as it is. Differentiate sin to the power of 4 theta. Differentiation of function to the power of n. Correct? Chain rule. It is of this form. Function to the power of n. What is answer? N into function to the power of n minus 1 into d by dx of function. Correct? Chain rule. So according to that, dx by d theta is equal to a into what is n? N is equal to 4 into function. What is function? Sin theta. 4 minus 1 into d theta. D by d theta of what? Function. What is function? Only sin theta. That is 4a into sin to the power of 3 theta. Differentiation of sin theta is cos theta. We got x derivative. Find out the derivative of y. What is y? b into cos to the power of 4 theta. It is nothing but sin to the power of 4 cos to the power of 4 theta means what? It is whole to the power of 4. So differentiating this dx dy by d theta b into follow the same function to the power of n formula 4 into cos to the power of 4 minus 1 into d by d theta of function cos theta. That is 4 into b cos to the power of 3 theta. Differentiation of cos theta is what? It is minus sin theta. Differentiation of cos theta is minus sin theta. Now, after getting dx by d theta and dy by d theta, get dy by dx. That is dy by d theta by dx by d theta. Dy by d theta is what? Minus 4b into cos cube theta into sin theta divided by dx by d theta. It is what? 4a into sin cube theta into cos theta. 4 cancel. Sin is cancelled with one sign. Remaining is what? Sin square. Correct? Cos cancel with cos. Remaining is cos square. So finally, dy by dx is what? Minus cos square theta divided by sin square theta. Sin theta by cos theta, tan theta. Cos theta by sin theta, cot theta. Therefore, it become what? Cot square theta. But our aim is to what? Getting dy by dx at theta is equal to pi by 4. Therefore, dy by dx at theta is equal to pi by 4 is equal to minus cot pi by 4 whole square. Don't get confused here. Keep minus as it is. Power is only for cot, not for minus. So minus is separate, cot is separate, right? Minus into for cot 45, it is 1 square. Some people say that minus, some students, minus 1 square is equal to plus 1. So it is not like that. It is minus of 1 square. Therefore, it is minus 1 only. Square is not for the negative sign. It is for only 1. Therefore, it is what? Minus 1. Right? If x is equal to a into cot square theta and y is equal to b into cosecant square theta, get dy by dx. Take x and y separately, differentiate them. So same procedure we have to follow here. Dx by d theta is equal to a into, it is cot theta whole square. Means use this formula, function to the power of n is n into function to the power of n minus 1 into d by dx of function. What is n here? 2 into cot to the power of 2 minus 1 into d by d theta of cot theta. Cot theta. It is 2a into cot to the power of 2 minus 1 is 1. Differentiation of cot theta is minus cosecant square theta. It is minus 2a into cot theta into cosecant square theta. Then take y. Y is equal to what? b into cosecant square theta. Use same procedure. Dy by d theta is b into function to the power of n into function to the power of n minus 1 into d by d theta of function. It is in theta, therefore we have to write d by d theta. It is equal to 2b into cosecant to the power of 1 into differentiation of cosecant theta minus cosecant theta into cot theta. Wherever you get negative like this, put a bracket. It is minus 2b into cosecant square theta into cot theta. Find dy by dx, that is equal to dy by d theta divided by dx by d theta. Write dy by d theta at numerator. It is minus 2b cosecant square theta into cot theta. 2 minus 2a into cot theta into cosecant square theta. 2 to get cancelled, minus minus cancel, cosecant square cancel, cot cancel. Remaining is what? B divided by a. B by a, right? If x is equal to 2t divided by 1 minus t square and y is equal to 1 minus t square divided by or 1 plus t square by 1 minus t square. See how the function is. Each function is are in the quotient form. How to differentiate them? We have to differentiate them with respect to t. Both are in quotient form, therefore use quotient rule. Dx by dt is equal to 1 minus t square v into d by dt of 2t minus 2t into d by dt of what? 1 minus t square. All divided by what? 1 minus t square whole square. I've used quotient rule, right? That is 1 minus t square into differentiation of 2t, 2 into 1, minus 2t into differentiation of 1 is 0, differentiation of t square is 2t, all divided by 1 minus t square whole square. Or it is, if I want to remove the bracket, multiply them. 2 into 1 is 2. 2 is multiplied with 1, it is 2. 2 is multiplied with minus t square, it is minus 2t square. Minus into minus plus 2t into 2t, 4t square by 1 minus t square whole square. Or it is 2 minus 2t square plus 4t square. T square is common, right? One is negative, other one is positive. Take the difference. It is plus 2t square divided by 1 minus t square whole square. Similarly, get divide by dt. Divide by dt. 1 minus t square into d by dt of what? 1 plus t square minus 1 plus t square into d by dt of what? 1 minus t square. All divided by 1 minus t square whole square. Correct? It is equal to 1 minus t square into differentiation of 1, 0, plus differentiation of t square 2t minus 1 plus t square into differentiation of 1, 0, minus differentiation of t square 2t, all divided by 1 minus t square whole square. Or it is equal to 0 plus 2t is what? 2t into 1 minus t square. Minus into minus plus 2t into 1 plus t square divided by 1 minus t square whole square. Remove the bracket. 2t into 1, 2t minus 2t into t square, 2t cube. Plus into plus 1 into 2t, 2t. Plus into plus 2t into t square, 2t cube, all divided by 1 minus t square whole square. See, plus tt cube minus 2t cube get cancelled. Remaining is 2t plus 2t, 4t by 1 minus t square whole square. We got dx by dt and dy by dt. Therefore, get dy by dx. It is dy by dt divided by dx by dt. Write dy by dt. What is dy by dt? It is 4t by 1 minus t square whole square, all divided by dx by dt. It is what? 2 plus 2t square divided by 1 minus t square whole square. See the denominators are both numerator and denominator, they are same, they get cancelled. What is remaining? 4t by 2 plus 2t square. Take 2 common, it is 1 plus t square, right? 2 1 ja, 2t, 2 2 ja. Finally, it is 2t divided by 1 plus t square, right? X is equal to a into log of cos t, and y is equal to b into cos of log t. They may give any functions, right? Take x a into log of cos t, differentiate it dx by dt, log of function. For log x it is 1 by x, for log t it is 1 by function into d by dt of cos t, that is a divided by cos t into differentiation of cos t is minus sin t, or we can take it as minus a into sin t by cos t is tan t, right? Y, differentiate y with respect to what? T, because it is in t only. Therefore dy by dt is equal to b into cos function. For cos x it is minus x, for cos function it is minus of sine function into d by dt of log, d by dt of log t, that is equal to minus b into sine of log t, differentiation of log t like 1 by x, log x 1 by x, for log t 1 by t. Using these two, get dy by dx. Therefore dy by dx is dy by dt divided by dx by dt. What is dy by dt? It is minus b into sine of log t into 1 by t divided by minus a into tan t. So minus minus cancel. So this denominator t goes to denominator, it becomes b into sine of log t divided by a into this t into tan t. Got it? So here the procedure very important. The function may be given in any form. It may be in product form or in the quotient form or in the function to the power of function or chain rule form. We have to follow the differentiation procedure. So far what we have did, right? So like that, if you work out more number of problems, then it will be easy to understand it, right? So with this, I am going to conclude my today's class. Thank you. If you have any question, please ask your questions.